trivial first test for the PR we are reviewing today, related to reconciliation, early PR. And uh, first of all, I would like to discuss about first tests. So I guess first tests are used when we would like to stress test our code, uh, related to different inputs, or like all the kind of inputs. So in the real world scenario, like the user can use any type of inputs. Like they can be millions and thousands of requests per second, and uh, we'll have to like ensure that the code we are writing manages all the like all the inputs correctly, which are like in the permissible range. So first tests are what we use to like test them locally before we go into production. And in Bitcoin Core, we have a directly called first in SRC and test, which which we use to like write first test. So this has a fuzz executable file here that when we like make the first test for uh, like running the first test, this makes all the CPP code that is inside this first directory executable and uh, like ready to be run when we are like testing it. So there are like two components that all the Bitcoin devs use when we are like writing this first test. So first is namespace. So namespace is where we would be like using, uh, where we will be putting all our data that we would like to use constantly or like repeatedly when we are writing first targets. And uh, because the reason because we do this is because when we are writing first targets, the code inside the first target is like uh, executed repeatedly, and like declaring variables and stuff we would like to use inside it would not be very like uh, very good like in a runtime perspective. And uh, majorly this is where you would be writing like also the uh, initial function like init functions that if you would like to use, or any functions uh, that are constantly being used in other first targets. So we can write multiple first targets in this, and uh, in a single CPP file, and like we can like execute them and name them like in different ways to like use it. So second part we would have in a first test file would be a first target. This is what we would be running when like we are fuzzing particular piece of code. And this will be like used repeatedly by the first provider. And like we can also name this first target, so all the first targets are named to like have them help us execute it. So let's say we'll write this first target as Bitshala test, and this will be the name of our test. So let's start writing the code. So I'll be writing a kind of a hello world kind of uh, this first test. Like it will be a very trivial test. You can like write more sophisticated or like more robust first test. There are a lot to be discussed uh, about first test, but like this a 1 hour window is like a very short period of time to discuss it. So like if I'd like to use this tests. First, I'd like to like have some initial conditions. So I like copy it from here. So this is the piece of code that I'll be using repeatedly in my first targets, and that is why I'm declaring it in my namespace. And now we'll write the first target that we'll be calling up, calling on. So the randomness is provided by the like this is we are using live fuzzer currently, which is a fuzzer provided by Google. I guess if I'm correct, and uh, this has a like a fuzzer provided that provides us randomization functions to like first write first test. So this is what we'll be using to like get access to randomizations. It has a lot of utility functions that we can use to call upon uh, various uh, like various types that we would like to call randomization on. We can uh, call like randomization on this floating points, integers, and also like all the variants of uint and ints. We can also have randomization in bytes. Like you can call upon anything that is a standard type to get randomization on, and this is like what uh, is the most necessary, like most important part of uh, what we'll be getting randomization on. So we just have to declare uh, this first data provider
Could
with
we also take
message.
a quick look at how one of those functions work under the hood, like how the
Uh,
randomness and like, advocacy.
yeah, so like mm, we can see here consume bytes with terminator. So like terminator is like a character that we would like to terminate it on, and this calls consume bytes in itself. So let's see what it does. Mm, yeah, so this is how like consume bytes string is like uh, provided to get randomization. So this is a just a assert statement.
Hmm.
Uh, so the size of this should be the size of uint t.
Yeah.
Uh, cannot convert the data to a string. Uh, so this is like condition to provide good input. So there are distinction between a good input and a bad input. A good input is a random input that is well in bounds of what the data will be requiring on.
Hmm.
So now we now it is a number bytes declared number of bytes with minimum of remaining bytes and numbytes, and what we get is a result which is we cast it uh, we cast the data and into a const string.
Oh, so is data PTR where the randomness is actually? Like, is that, I guess that's managed in some other class? Like, where does the randomness
Yeah,
actually come from?
yeah, like this. I guess this is from yeah. This data pointer is I guess what is getting the randomness on.
Hmm.
Yeah,
Okay, interesting.
this data pointer and the remaining bytes are two essential things compared, including data and size. Uh, so basically, what happens is this data pointers size varies according to data,
Hmm.
and then also there is like casting differentiations. So different castings would be like turning it into a different data type with different size. We
Yeah,
also have this remaining bytes,
makes
and
sense.
then we get
Huge appreciation to the people who wrote the class like
yeah,
that. Like they've thought of all the
yeah.
different
There,
parts.
there is a lot of thought that goes into like providing good first data.
Yeah, and just writing good C++ code, like the way he's written, like the way the people have written all the
Yeah,
code. Yeah, I guess we can move
yeah,
on.
definitely.
Yeah.
Yeah, yeah. So we can just get a first data provider. Mm, so now we'll be like calling upon the buffer uh, to get. So we can't use this line in like any other uh, function. We can only like write this line. We can only get the fuzzing data provider inside a fuzz target file. It just because it does not let us to. There is no sense in like calling a fuzzing provider in any other piece of code. So we can like write while loops in a first target. So in this we can call upon a limited while, and it has two components. First is condition, and the second is the number of uh, or the limit that we would require for this first first target to run on. So like I'll just write it true because I would like to run it every time, and 1000 times is what I'd be running it on, running it for. And now I'll start writing the code. So the a very easy way to write first test is like convert a unit test into a first test. So the first test can be like thought of as a unit test where we are providing random inputs to stress test the code and to check if it behaves properly in every scenario. So what I'll be doing is I'll be taking this forget peer test and register peer test and combining it to write a first test inside this first target. So I'll just create a node ID with a peer ID, and if I'm if I would like to call uh, a randomization of fuzz input, I would just use a fuzz data provider and like use the functions that are like coming here to call uh, this randomization, this fuzz input, and I'll just take a uint 8 for now. Yes, this is fine, and like this is how we can like call uh, a first input inside a function, or like inside like a first input we are providing to any of the variable that we would be using. And to assert conditions here we just use assert. So unlike boost libraries, we would be like using boost check and boost require. Well, here we'll be using just assert statements to like get like enforce conditions in our uh, like uh, code that we would be like writing on. So like this is first I'm like creating a peer ID and I'm ensuring that this is not registered, and then I'll just pre-register this uh, peer with uh, my tracker and enforce that this peer is still not registered because I have not called the register peer function. This is just uh, enforcing uh, that pre-registration does not mean that the peer has registered with us. So this is mm, basics basic stuff. And now like we can call we would need that peer to have more randomizations. uh, we would try to like include randomizations everywhere where we would like can provide randomizations in our code. So we would uh, also provide randomization for if our peer is inbound or not. We will just provide uh, a consume bool for that. We'll be also using uh, peer reconciliation version uh, for this. And I'll be intentionally writing it wrong to just demonstrate that we'll have how it like crashes it when there is a crash that has happened or like it has found a bug in it. So peer reconciliation version does fails when there is uh, a zero or uh, a peer reconciliation version which is not supported by us. And uh, we can just uh, but we but the function that we'll be calling upon is just consume integral again. So what consume integral does is it will we have two consume integrals function. I'll be using consume integral here to demonstrate this, that uh, how a fuzz input crashes uh, when there is a bad input. So I'll just be completing the code for the fuzz input for the first test. Yeah, so we have like all the important inputs now. I'll be registering this with uh, all the inputs that we have initialized now. So we have registered the peer, and we'll just assert that our peer is registered. We'll now add a statement to forget the peer. Yeah, with this, our now code has our first code has been completed. We will just mm, make it.
Like, yeah, you can also, in case anyone's not familiar, to run first tests, you need to give a different set of configuration flags to enable it compared to when you normally
Yeah,
build core.
yeah. We like this is the complete list of flags that you will have to give. So this is the main line, the configuration flag with enable first and with sanitizers, and these are just like linkers if you face any issues. This is just a setup for like uh, Linux based machine which I'm using. Might be different for like Mac OS and Windows. Yeah, but in general we can use this.
Oh, those were the exports
So
which were
yeah.
giving you trouble.
Sorry.
Oh, those were the exports which you said were giving you trouble before?
Yeah, these were the exports needed
Okay, okay.
because the library was not recognizing all the.
Oh, wow, okay.
Yeah.
Nice.
Yeah, so to run the first test, what we would do is we'd call this. What we have done is that we call the first is equal to with the first test, the name of the first target that we have written, and this is the executable file src test first response to the executable file to run the first test. So this code would be failing because this consume integral line has a fault that we will be provided with zero in our inputs definitely, and that is a failing condition for uh, our code because reconciliation version does not support zero. The default version is one. So I'll just run it, and yeah, this is how it would look if there is a condition that a code is failed. So this has failed is peer registered in the line 36. So this is good, and this has failed because of this line. Like you can, there is not a debug option to get more info, but you can just write print statements to get more info about it.
Oh,
What I'll just do is,
I think you can run a debugger on it.
uh, like I'm not aware of if there is a debugger that we can run with it. I'll just research it and like we'll update.
Yeah, yeah, no, let me just check.
Yeah, so ideally it should run infinitely because the first test would run uh, infinitely until it finds a condition where it crashes. This is what an ideal uh, first test would do, like this. So this is the currently the executions per second is really low because of this function is not a, like this first test is not a very optimized first test. Uh, in general, 1000 executions per second is more favorable, like it is kind of a benchmark, and you should write like really good first test and with like really good inputs. So this would run infinitely until it finds a bug, and uh, you'll just have to like interrupt it manually to like stop this. Also, if you would like to get, what people would do is, uh, suppose like here we have more uh, more of a complicated type of first test. So like, here we have a transaction being made uh, with the first inputs, and people like would like to use a certain, like if you know that there are some inputs that are a point of concern for your code, you can just like create assets or fuzzing corpus for your uh, first test. So fuzzing corpus is just inputs that you are providing uh, in your uh, first target. So if you would like to know, you can like look into this uh, fuzzing with corpus. Yes, this is the one. You can like write where the fuzzing corpus is for your uh, this first target, and then you can run with this uh, your piece of inputs that you would like to test this code on. But generally, it is like advisable to write uh, this code only on the fuzz inputs here, but like in special cases, which uh, when you know that there are some known uh, issues or known test cases that are really uh, like a point of concern, you can like put directly that inputs and in a corpus and then provide it. So one disadvantage of first test is that if you know that there is a certain yeah, there is a certain input that might be troublesome for your code, if the amount of like range of inputs is large, you would take a lot of time to, the test would take a lot of time to get to that input. So in that scenarios, custom first corpus is like really suitable. And like now we can like look into like this first coverage report. So you can go to this side and look for the reports of what lines that are included. So a really good use case of first test is to increase the coverage report or coverage of the code, because really secure code base will have a lot of lines of tests per piece, per a line of code. And for a current PR, we can like you can look into this code, this website code check, where we can like this provides us a very informative report about the codes that are like the code lines that are not being used. Like so currently in transaction reconciliation.cpp, this is not used, and this is not used, and like you can just check for the lines which are not being used and then write code for it. So what I'll be doing now is, this piece of code is like not being used in the transaction reconciliation.cpp uh, in the main master PR. So I'll be writing test case for, or a test for it. So that should be pretty easy. Uh, I just what we would like to for writing a unit test. Uh, since we are using libboost, uh, we can just replace first target with a boost auto test case. So this is how we'll be declaring our uh, name of the test we would be writing, and let's name it breach max fan out. And I'll just be using this. So these are the base helpers that I'll be using. So in the line of code, I can see here. I'll just go to my file and check on this where it is being used. So it is like really troublesome to just navigate. So if we are going, if we are like writing tests for a very uh, like a file like net.cpp or uh, nettest.cpp, uh, we would know that it is being used in a lot of tests and a lot of files. So it is really difficult to navigate uh, where the test is coming from. So you will just have to take your time and uh, look for the for any piece of code that you think that the test can hit that piece of code. So this is the piece of code currently that we'll be writing to include in the in the coverage, and we'll just see that this line is being checked, but it is uh, never being utilized. So we would like to change that. This is this is the reason because the cache never fills, and I will write a test that will fill the cache for it. So I'll just first include some number of inbound peers. So the number of peers we'll be reconciling with is 10% of what we'll be declaring. So like it would be a 50-50% chance of peers 3 or peer 4 we are reconciling with, and I'll just write a loop for this. I'll be pre-registering this peer this, and if we are like in the first test we would use asserts to like enforce some conditions on it, and here we'll be using this boost require equal. So you can check the boost files to gain more insights about uh, which of uh, these like enforcing run code we would be using. Normally boost check equal, boost check and boost require are sufficient enough for us, and we'll be using those only for us for our uh, test. And So we have uh, expected a condition. Now we would just need for this to breach our maximum limit of the cache. So we'll be writing this again. We'll be introducing so to breach the cache size. We would like to introduce a number of witness transaction IDs more than the cache size limit. So I'll just uh, for the safe side include 4,000 transaction IDs. And this should be fine.